Today we will going to start the logarithm. Logarithm. The equation a raised to y equal to x, where x is argument, y is exponent. So y is the exponent to which a must be raised to obtain x. Y is a exponent to which a should be raised to obtain x, argument x. And log of x to the base a. This is the reading of log of x with base a. Consider a small example. X is equal to log of 4 to the base 8. So 8 raised to x is equal to 4. 2 raised to 3x. 2 raised to 2. 3x equal to 2. X is equal to 2 by 3. Similarly, log of 3, log of x to the base 4 is equal to 3 by 2. So 4 raised to 3 by 2 equal to x. X is equal to cube root of it. X is equal to 2. So this is the concept of logarithm. Another logarithm is natural logarithm. Natural logarithm. Natural in many practical applications, the number e is used as a base of the logarithm is called natural logarithm. It is read as ln x. Natural logarithm is small e l n x. ln x. So ln x is log of x to the base e. ln x 12 equal to 2.4849. ln x e to the power 10 equal to 20. ln x to the power e equal to half. So now properties of logarithm. Properties of logarithms. Number first property is product rule. The product rule is log of x to the base a, log of xy to the base a, which is equal to log of x to the base a plus log of y to the base a. Quotient rule. Quotient. Quotient rule. Log of x by y to the base a is equal to log of x to the base a minus log of y to the base b. change of base rule, change of base rule, which is equal to log of x to the base a, which is equal to log of x to the base new base b, log of a to the base b. So there is a log of 17 to the base 5 equal to ln x 17 upon ln x 5 equal to 1.7604. Similarly, log zero point 0.1 to the base 2 equal to log zero point 0.1 upon log 2, which is equal to minus 3.3219. So this is the concept of logarithm and some properties of the logarithm. Next, we will discuss the limit of a function. Limit of a function. The basic is, suppose a and b. Here a and b are the two sets. The numbers a and b are open interval. A and B in open interval, whereas A and B are in closed interval. This is open interval, this is closed interval. Limit x tends to A, f of x is equal to L. This is the designation of limit. Now let us know the formulae of limit. Limit x tends to A, kx equal to ka. Limit x tends to A, f of x plus minus g of x equal to limit x A, f of x plus limit x tends to A, g of x. Limit x tends to A, f of x into g of x. Limit x tends to A, f of x into limit x tends to A, g of x. Limit x tends to A, f of x divided by g of x equal to limit x tends to A, f of x divided by limit x tends to A, g of x. Limit x tends to A, f of g of x equal to function of limit x tends to A, g of x. Similarly, limit x tends to A, e to the power g of x equal to e to the power limit x tends to a g of x limit x tends to a log of g of x equal to log limit x tends to a g of x to this. So limit can be derived from direct method, factorization method, rationalization method, simplification method. These are the methods to obtain the limit. Standard formulae: limit x tends to a x raised to n a raised to n upon x minus a is equal to n into a raised to n minus 1. Limit x tends to a x to the power n a to the power n x to the power n a to the power n equal to n by m a to the power n minus m. Now method rationalization method. So in that, the limit of trigonometric function limit x tends to a sin x is equal to sin a. In a rationalization method, we just add a numerator and denominator opposite sign of the equation. Limit x tends to a sin x is equal to sin a. Limit x tends to a cos x is equal to cos a. Limit x tends to 0 sin x upon x is equal to 1. Limit x tends to 0 tan of x by x is equal to 1. Limit x tends to 0 x upon sin x equal to 1. These are the formulas on limit. The next is limit x tends to 0. Limit x tends to 0 sin ax upon sin bx is equal to a by b. Limit x tends to 0 tan of ax upon tan of bx is equal to a by b. Limit x tends to 0 sin inverse x upon x equal to 1. Limit x tends to 0 tan inverse x by x equal to 1. limit x tends to 0 sin x degree upon x is equal to pi by 180. Limit x tends to 0 tan of x degree upon x is equal to pi by 180. Next is limit x tends to 0 1 minus cos x upon x square is equal to half. Limit x tends to 0 1 minus cos kx x square is equal to k square by 2. Limit x tends to 0 1 minus cos ax upon 1 minus cos bx equal to a square by b square. Limit x tends to 0 cos ax minus cos bx upon x square is equal to b square minus a square by 2. B square minus a square by 2. Limit x tends to 0 cos ax minus cos bx cos cx cos dx equal to a square minus b square c square minus d square. Now limits of exponential and logarithmic function. Limit of x tends to 0 1 plus x 1 by x is equal to e. Limit of x tends to 0 1 plus kx raised to 1 by x is equal to e raised to k. Limit x tends to 0 1 plus kx raised to 1 by x equal to e raised to k. Limit of x tends to 0 1 plus ax upon 1 plus bx raised to 1 by x is equal to e raised to a minus b. Limit of x tends to 0 e raised to x minus 1 upon x is equal to k. Limit x tends to 0 a raised to x minus 1 upon x equal to log of a. Limit x tends to 0 a raised to kx minus 1 upon x equal to k log a. Limit x tends to 0 log 1 plus x upon x equal to 1. Limit x tends to 0 log of 1 plus kx upon x is equal to k. Limit x tends to infinity 1 by x is equal to 0 limit extends to infinity 1 upon x raised to k equal to 0, here k greater than 0. Limit extends to infinity 1 plus 1 by x raised to x is equal to e. Limit extends to infinity 1 plus 1 by x raised to x is equal to e. Limit x tends to infinity e raised to x equal to 0. Look this. Next is limit extends to infinity x tan 1 by x equal to 1. X tan 1 by x equal to 1. Limit extends to infinity e raised to minus x is equal to 0. Limit extends to infinity e raised to x equal to 0. If the limit contains 0 by 0 form or infinity by infinity form, then use L'Hospital's rule. L'Hospital rule. In that we derive the function by taking the derivative of numerator and denominator respectively. So limit first problem of limit. Let us study limit x tends to 0 a plus x raised to minus 2 minus a raised to minus 2. Here put x raised to 0 which is equal to 0 by direct putting the value of x is equal to 0. In that case its value is 0. Next is limit x tends to 3 4x plus 5 x minus 3 is put the value 4 into 3 plus 5 3 minus 3 equal to 0. Limit x tends to 3. Next is limit x tends to 0 x plus 2 divided by 2 plus x plus 2 minus x which is equal to limit x tends to 0 0 plus 2 upon square root 2 plus 0 plus 2 minus 0 1 by root 2. Limit x tends to root 2 x square plus root 2x minus 4 x square minus 3 root 2x plus 4. So we have to apply L'Hospital's rule. By L'Hospital's rule, x square derivative is 2x plus root 2 as it is, x derivative is 1. This is 2x minus 3 root 2. So put the value of limit x tends to root 2. 2 root 2 plus root 2. 2 root 2 minus 3 root 2, which is equal to minus 3. Next is limit x tends to 3. X cubed minus x minus 24. X cubed minus 6x square plus 9x. Limit x tends to 3. X minus 3. X square plus 3x plus 8 divided by x into x minus 3. Here it is equal to limit x tends to 3. X square plus 3x plus 8 upon x minus 3. 9 plus 9 plus 8. 3 into 0. 26 by 0. So limit does not exist. Next, limit x tends to 2 is equal to x square minus x minus 2 bracket raised to 20 divided by x cube minus 12x plus 16 raised to 10, which is equal to x minus 2 x plus 1 whole divided by 20 x minus 2 x minus 2 x minus 4 raised to 10. So limit x tends to 2. X minus 2 bracket raised to 20 x plus 1 bracket raised to 20 x minus 2 bracket raised to 20 x plus 4 bracket raised to 10. So it is equal to 3 raised to 20, 6 raised to 10, 3 by 2 raised to 10. Next problem is limit x tends to 1. square root x square minus 1 plus square root x minus 1 upon x cube minus 1 x minus 1 x plus 1 plus square root x minus 1 square root x minus 1 square root x square plus x plus 1 limit x minus 1 x minus 1 x minus 1 bracket x plus 1 plus 1 x square plus x plus 1 which is equal to put the limit here. This get cancels. Root 2 plus 1 upon root 3. Next problem, limit x tends to b by a upon ax minus b upon ax square minus bx. Limit x tends to b by a upon ax minus b upon x into ax minus b. So limit x tends to b by ax minus b x upon ax minus b. Limit x tends to b by is equal to 1 by x, which is equal to a by b. Look this. Now let us look the another problem. Limit x tends to 3 1 upon x square minus 11x plus 24 plus 1 upon x square minus x minus 6. Limit x tends to 3 1 upon x minus 3 x minus 8 plus 1 upon x minus 3 x plus 2. So limit x tends to 3 2 upon x minus 3 upon x minus 3 x plus 2 x minus 8, which is equal to 2 upon 3 plus 2 3 minus 8 minus 2 by 25. That's all.